Welcome back to our next Global Networking Forum program session here in our Duma Hall. And we will continue the program with another exciting and international panel organized by Thales Alenia Space on the topic of lunar surface infrastructure. I would like to welcome our two moderators of this session, Dr. Maria Antonietta Perino. She is connected remotely. And here with us we have Eleonora Zeminiani as a moderator on site. Welcome, Maria Antonietta and Eleonora. The floor is yours. Please.
Thank you. Thank you, Christian, very much. I hope you can hear me. It's so nice to see so many friends, even if in a remote way. Thanks to the organizer, to the GLEX organizer, for offering us the possibility to share with you all the enthusiasm we put in supporting the development of this lunar exploration. Months ago, we connected with different experts, I shall say, from all over the world, as much motivated as we are in Thales Alenia Space to sustain lunar exploration, and we decided to propose a conversation, again among friends, regarding the topic of how we can all together build up a lunar surface infrastructure. As Christian mentioned, my name is Maria Antonietta Perino. I work in Thales Alenia Space in Torino. Normally, I should be there with you. I am there with, for sure, with my spirit, and I am lucky because I have a colleague of mine there with you, Eleonora Zeminiani, that will help me conducting this conversation. I believe that this GNF itself is the real proof that altogether we can overcome any obstacle. The GLEX organizers succeeded in offering you an insight conference. From our little point of view, we, the panelists involved in this GNF, got together via different teleconferences, and we are doing our best to carry on the conversation, some of us in remote, some in the States, some in Europe, some other colleagues there with you. And so let's just enjoy this, how can I say, exchange of opinions about how we could altogether build up a lunar surface infrastructure. So I will give the floor to John. Each of the panel will briefly introduce themselves and then share a few slides, few thoughts, and then Eleonora herself will propose them some questions, and they will offer their answers. So good to see you, Eleonora. Just be there to advance the presentation. So John, tell us about yourself from the States.
Grazie, Maria, and Dore Den to all of you in St. Petersburg. I'm John Connolly. I've been working lunar exploration for most of my career in terms of lunar lander design and surface system design and even Mars mission design, all with humans in mind, of course. And so I'm pleased to talk to you today about NASA's concept for the initial lunar infrastructure. And this is called Artemis Base Camp. It is NASA's initial foothold on the lunar surface. So you see from this graphic that there are some elements that are key to the initial infrastructure. Habitation, you see a habitat on a lander. Mobility, you see different types of rovers, both pressurized and unpressurized. Services, things like power and communication, very important to that initial lunar infrastructure. And then, of course, enabling resource exploration and production. Doing great science and doing all this in order to prepare for Mars. So that is what NASA's concept for Artemis Space Camp and our idea of the initial lunar infrastructure is all about. Next slide, please. So this shows a little more detail on then the connection of the lunar infrastructure to our ultimate goal, which is sending people to Mars, or at least our horizon goal. So you see that the Artemis Base Camp is not an end in itself. It is a stepping stone along the way in order to test the systems, the technologies, the operations that will get you to the next step. So you see from the top, Gateway feeds forward to the Mars Transit Vehicle, lunar landers feed forward to Mars landers, lunar rovers feed forward to Mars rovers, habitats to Mars habitats, power systems to Mars power systems, and in general, all of the operations that you will do on the moon will teach you about how to relearn the art of exploration so that you can advance that further out into the solar system. So while the moon and Mars are separate destinations, each very scientifically interesting in their own right, and there may not be a one-for-one mapping in all these cases. In terms of surface infrastructure, they are more alike than they are different. So NASA's goal, the Artemis Base Camp, is to put down these essential pieces of infrastructure, learn how to survive on the planet for long periods of time, and use that knowledge to move on forward to Mars. Thank you.
Very good, John. Thank you. And now I would kindly ask a colleague of mine, Roberto Provera, to share with us what we do in Torino in support to lunar exploration. Roberto.
Initiatives and innovation for exploration and science in Thales Alenia Space. And this time humanity will go to the moon to stay, and beside the transportation means, of course, the habitats will play a key role. Will play a key role for to sustain and to establish the human presence beyond LEO. And Thales Alenia Space is heavily engaged in the development of these new habitats, starting from the Lunar Gateway. Namely, we are developing for Northrop Grumman and NASA the pressurized vessel of HALO, the first habitat orbiting around the moon, and for the European Space Agency, the International Hub, and the Esprit, where we are a prime contractor. The design of those elements is rooted into what we learned in the International Space Station project, with some significant differences. Mainly, we are targeting a modular approach whenever feasible. Of course, we have to take to consider the different environment in which we are moving, lunar orbit and lunar surface rather than LEO, and some modernization that may be required, like new architecture for command and control, data command and control. Next slide, please. And as far as the next step is concerned, the lunar surface, the infrastructure of a lunar surface, as we have already seen, and for those who were connected when the president of the Italian Space Agency had spoke this afternoon, Italy is targeting to work on the infrastructure for the habitat for the lunar surface. And in fact, for the Italian Space Agency, we are developing a series of studies at the system level for the understanding of how this initial infrastructure could look like. And in particular, we are not only developing some system study level, but we are already working at breadboarding and some technologies that will be required as a bricks for all the elements that will be necessary for building the initial infrastructure. So basically, we have already started our journey to the moon. Thanks.
So Roberto, not only super reliable habitat, but also very comfortable from inside. And now I will ask Matt Duggan from Boeing to share with us what he's planning to do and is doing, in fact. Matt.
My name is Matthew Duggan. I am the Mission Operations Manager with the Space and Launch Division of the Boeing Company in Houston, Texas. I've been involved in human spaceflight throughout my career, particularly the International Space Station program, and of course we're looking forward to the upcoming flights of both the Space Launch System and the CST-100 Starliner. I'm going to talk a little bit about lunar communication infrastructure and how that can help us as we expand our presence on the moon. You know, all of us today carry the cell phone with us, and that uses communication, our infrastructure, to keep us in touch with each other. We can talk to anyone who's in the same room or someone who's on the other side of the planet. And building a similar infrastructure network like that on the moon can connect all of the different assets that we put on the surface of the moon and help us communicate back to Earth. So there's a great convenience in doing that. But beyond the convenience of it, I think there's two very important practical aspects. One is extending the footprint on the moon, which you need line of sight for, and the other is reducing power and mass. So talking first about the line of sight to the moon, the radio frequencies we use, or even the optical methods of communication, require that the receiving station see the transmitting station. You can't transmit through a mountain. You can't transmit through the moon itself. And so that means that on large parts of the moon, you're out of luck. If you don't see the Earth in the sky above you, you can't send a signal to it. That's all of the far side of the moon, never sees the Earth. And even the south pole of the moon, where NASA is interested in landing human astronauts, if you can see the Earth, it's going to be very low on the horizon and might be obscured by the mountains. And of course, if you drive into a crater, you're probably not going to see the Earth at all. So all of our exploration on the moon would be enhanced by having a relay satellite overhead that lets you talk to it rather than having to communicate all the way back to Earth. And then the next slide, please. I'd also point out that the power and mass of everything you land on the moon can be improved with this kind of lunar communication satellite. Generally speaking, the farther you want to send a signal and the more bandwidth you want that signal to have, you require a larger communication system, both the power that you put into it and the pure mass of it from the size of the antenna. So if you ask all those different elements you see there on the screen to carry their own communication system that can reach all the way back to Earth, you can see how you're very much duplicating those systems and adding mass after mass after mass. Whereas if all of those systems only had to talk up to something in orbit, say 10,000 kilometers away rather than hundreds of thousands of kilometers away, their communication system shrinks accordingly. So all of that mass you're saving and not spending on a communication system is more mass that you can devote to science and exploration on the lunar surface. So I would certainly advocate that a lunar communications architecture is a necessary part of surface infrastructure.
Yes, Matt, thanks for being concerned that we are all connected. Yes, and now I will invite Steve Squires, remotely connected from the United States, to share with us what Blue Origin is putting on the table to sustain lunar exploration. Please, Steve, floor is yours.
Very much. Very glad to be here. My name is Steve Squires. I am Chief Scientist at Blue Origin. I've been at Blue for about a year and a half now. Prior to that, I spent more decades than I care to think about doing Mars exploration, Mars rovers. It was a great pleasure to see some of my friends and colleagues from the Mars rover world in the previous session. And I'm going to talk very briefly about Blue Origin and our vision for what we're going to be doing on the lunar surface. So if we could show my first slide. What Blue Origin is all about at the moon right now is landing cargo and getting cargo down on the lunar surface to emplace some of the infrastructure that we're going to be talking about in this session. And can everybody see my slide? I'm just seeing myself. There we go. Our vehicle for doing that is Blue Moon. This is a vehicle that is capable of landing cargo on the lunar surface. We have a single launch capability where initially this lander will be able to put about 1 metric ton of cargo down on the surface with a single launch. This is a number that will increase over time, but that's what we expect to do on the first mission. We also have a multiple launch capability where by operating this vehicle in tandem with a transfer stage, we can put more than 10 metric tons down on the surface. So it's a very, very capable cargo delivery vehicle that can be used to emplace infrastructure onto the surface and to begin this process of building up a real permanent human presence on the moon. To do that, you've got to send stuff, and we can send a lot of stuff with this vehicle. If I could have my next slide, please. This is not a PowerPoint spacecraft. We have done a lot of technology maturation work. We've done a lot of testing. We've built a lot of hardware. We're making smoke and fire with the rocket engine. It's a vehicle that has a lot of development effort behind it. The technology maturation activities that we conducted in large part focus on that BE-7 engine that you see firing. You see a test of the combustion chamber in the top row there. This is a LOX hydrogen engine, so it can make use of water resources if those are available in the lunar polar regions to get lunar-derived propellants. It's a deeply throttleable engine so that it can be used to land big, heavy cargoes on the moon. We expect to eventually put these into reusable landers, so we'll take off from the moon with the same engine at some point in the future. We have built hardware for testing cryogenic fluid management, very important when you're dealing especially with liquid hydrogen. We have tested landing sensors using our new Shepard vehicle. We have used those very same sensors that we intend to use to land Blue Moon on the lunar surface. We've flown them and tested them on our new Shepard vehicle in West Texas. We've built landing legs, we've built fuel cells, we've built offloading hardware. You can see we've built a full-scale, one-to-one scale assembly pathfinder of the spacecraft that is at our facility in Huntsville, Alabama. So this is our future. This is what we intend to be landing on the moon as soon as we get the opportunity, and I'm very pleased to be at a session here about lunar surface infrastructure, because really that's what Blue Moon is all about. Thank you.
And that's the reason why I was really pleased to invite you to join the discussion, Steve. And now I leave the floor to a dear friend of mine, Barbara Imhoff, that will share with us the beautiful things we could do using the in situ material. Barbara is an architect, so Barbara, please introduce yourself.
Thank you, Maria, for the invitation. Also, thanks to the GLEX organizers that I can be here on the panel. My name is Barbara Imhoff. I'm a space architect, but I'm also a co-founder and co-manager of Liquify. And I've been working for space exploration projects, and more recently with a focus on lunar exploration and gateway for more than 20 years. And I'd like to present to you a project we were partner in, that is Project Regolith, sintering regolith with solar light to build ISRO habitats. And if you can advance one further. So what is solar sintering? Solar sintering uses two components on the moon, which are there in abundance. It is the regolith, the sand, and the sun, and it focuses the sunlight with no binder to actually create, to create interlocking elements, for example, next. And with these three-dimensional interlocking elements, we can build shelters, radiation shelters, and micrometeor protection shelters, where we can also house, well, first of all, the astronaut crews, but then it can be also shelters for the machinery. And we can construct flat ground stabilizing elements. Next, please. And I have here, when you see me here also on the screen, Maybe you can also show my portrait on the screen. I have here a couple of these elements. And these elements are actually these three-dimensional interlocking parts. They are the geometries which we were developing as architects. If you can advance the slides again. Thank you. So we were doing three under the lead of the German Aerospace Center in Cologne and Professor Matthias Sperl. We were doing different printing campaigns in ambient conditions and a larger mobile printer setup, which it's the bottom picture on the left. And when you imagine that this setup being advanced and also has wheels, then it could actually also function with the moving Fresnel lens as a kind of mobile device which can solar sinter these elements. And then one other campaign was the vacuum printer campaign. The technology still needs to be developed, but with the geometries we developed, we also found out that we will have to use compact geometries with obtuse angles, large elements, and probably will also have a survey process in parallel to the building process. And with the final slide, then this is the picture of how such a moon base can look like. Thank you.
Thank you, Barbara. We'll come to the possible, architecture before the end of our conversation. So I kindly would like to invite René Pischel, that is there in St. Petersburg, to share with us what ESA is currently doing to sustain lunar exploration. René, 3 minutes for you.
Thank you very much. So my name is René Pischel. I'm the head of the ESA Moscow office. And obviously I'm talking on behalf of the project team, who gave me all the information I'm telling you right now. And I want to talk about the European Large Logistics Lender, EL3, which in the moment is still in the study phase and is actually a proposal, but hopefully it will become real hardware very soon. As you can see, hopefully in the slide, yes, the European Large Logistics Lender is being designed to carry different cargoes. This can be also cargoes which can land in the vicinity of human exploration camps, but it can be also self-standing science missions and even sample return missions. And it is clear that the EL3 lender is another part, an additional part to the participation of ESA in lunar exploration. And so far these parts are the European Service Module in the Orion spacecraft and the ESA parts in the Gateway. And of course, as we know, if you want to do exploration on the surface of the moon, you have to land. So building a lander is obviously a smart thing to do. And as you can see here on the table, the technical parameters are rather challenging. So the plan is to land on the surface of the moon 1.8 tons and to have a size of 4.5 meters in diameter and up to 6 meters height. And the idea is to have the first launch on an Ariane 64 launcher in 2029. And hopefully by then, or maybe a bit later than that, we will actually see the first European walking on the moon in the frame of the Artemis program. So it would be really nice to have these two things going together. Can we have the next slide, please? And obviously, one of the objectives of the development of this large lander is to give Europe the capability to autonomously land on the lunar surface. And it also shows that this is not a one-off lander, but it is a program of landers which can fulfill different missions. Actually, this design phase has been initiated at the last ministerial conference in 2019, Space 19 Plus, and the Council of Ministers has tasked industry or the agency and then the industry to study two mission types. One is a logistic support for human exploration mission, and the second one is a self-standing science mission, for which we actually got quite a number of proposals after an announcement of opportunity. And as you can see also on the previous slide, on this slide, the design is pretty much straightforward. We have a propulsion unit, then sort of an adapter, which shall be in between the propulsion unit and the cargo unit. The last slide shows that we all hope for an approval of this program in the end of next year, when we have the next council meeting of our agency at ministerial level in 2022. Thank you.
Thank you, and thanks to all of our panelists for these interesting viewpoints on moon exploration. And this plurality of viewpoints actually speaks very well to the first question, where we would like to hear the different perspectives and propositions from agency and industry about motivation and benefits. So I would like to call on John and Matt to answer this question. Which are the strongest motivations in going back to the moon for different players, different nations, and which are the benefits for humankind? John, would you like to go first with the agency perspective?
Yes, thank you. Well, NASA's plan for this decade is for our Artemis program to lay the foundation for sustained long-term lunar presence on the lunar surface. And we do this via our Artemis Base Camp concept, which calls for building up lunar surface infrastructure elements with the help of our commercial and international partners. And that includes habitats, mobility systems, and all the support things you need on the surface for long-term operations and logistics. So NASA's long-term goal and the U.S. exploration approach has always been to use the lunar surface as a test bed for sending humans to Mars. So the moon helps us to get to Mars. And in addition to help us getting to Mars, there's obviously other benefits in going back to the moon, continuing the legacy of Apollo science investigations, demonstrating new technologies, and even stimulating new economic activity. So it's multifaceted, but in general, moon on the way to Mars, and lots of other benefits that revolve around that.
Thank you. And Matt?
Thanks. Yeah, I would agree that there is a huge emotional aspect to going back to the moon. It's inspirational to put humans on the surface of the moon and get us there. From the industry side, though, I would also agree that it's a great stepping stone. We need to build those technologies first at the moon and make sure we understand them before we commit humans to the very long trip to Mars that you can't get away from easily once you're on the trip. So the moon is an excellent testing ground for Mars in many ways, and we need to start putting our systems there. I think we're also at the point where numerous nations and companies are starting to have some very good deep space exploration systems standing by themselves. But we need to start combining those together and learning how to get strength on strength from them and combining them in new and unexpected ways we may not even anticipate yet, so that we get the most out of those systems, push the humans sooner and faster to get to the surface of the moon and then on to Mars.
Matt, you perfectly said what I was going to ask John. It's clear that from your previous presentation, it's evident that we are talking about an open architecture. to be developed on the moon, where in fact different players can contribute with different building blocks making up the overall architecture. So when we prepare this GNF, we really enjoy to exchange, and we started to ask each other, John, if you have to pick up one building block for you to build up, to start the beginning of this lunar surface infrastructure, which would be the first building block, the strategic building block for you? Which building block would you pick up first? John?
Well, thanks. I think I like the pressurized rover the best. It combines mobility and habitation into one. And you could use it on early missions, as both your mobility system and your habitat. It's essentially your motorhome or camper on the lunar surface for short duration missions. So I like that, and not just because I like the movie The Martian, and it does a lot in that. Roberto, what do you think is the most important building block?
Side of the habitats, of course. I would go to a surface habitat that could be the first element and act as serve as a node and have airlock functionalities in order to be able to build the future base camp. Matt?
And I will go back again to the lunar communication infrastructure. But I think why I would pick that as the first one is that these kinds of satellites that could give us a very capable communication system on the moon are actually very small satellites. They're not the giant communication satellites we use in Earth orbit. And so those small satellites are very much in the grasp of multiple nations, multiple space agencies, multiple companies. Any number of organizations on Earth today could be building those satellites, and due to their small size, using many different launchers to get them into lunar orbit. So that could be a very viable first step for any country, any company on Earth. Steve.
We cannot hear you, Steve. Hold on. Okay.
I'm a very practical person, and I really believe that one of the very first things that we have to build on the lunar surface as we do put our infrastructure in place is going to be landing and launch pads. We know from Apollo that when you land on the lunar surface, engine exhaust will accelerate regolith grains to velocities of kilometers per second. As soon as you start doing multiple landings at one location, every landing is going to endanger infrastructure that's already in place unless you have taken the steps to minimize that mobilization of the regolith. The way to do that is with well-constructed pads that you can land on, that you can launch from, and that prevent grains of regolith being mobilized and becoming a risk to the other infrastructure around it. So I think landing and launch pads are just about the first thing that we have to build. Barbara?
Yes, I think we really need additive layer manufacturing technologies, because when we see the moon as a stepping stone for Mars, then we need to build sustainable bases. So with all the infrastructure elements which were mentioned before, and Roberto's habitat, I think we need some protection against radiation and micrometeorites, and we need to advance these technologies so that they're ready when we want to live on the moon for longer-term missions, and also to ensure that when we are on Mars, we can also protect ourselves from the environment.
And so René?
And René is the last one.
I agree with Steve that landing is really essential, and therefore I would say a lander is really the first building block which has to be made really successful and sophisticated.
So what I'm hearing is that moon exploration is much more than what we usually associate with space travel, traditional space exploration. And in particular, it seems there's room for a lot of new players to join this game. So I would like to hear from two people that, although very well known in the space community, are somehow representing these new players, emerging forces. And I'm thinking commercial players, private capital, SMEs, non-space players. And I would like to hear from Steve and Barbara that represent commercial players. What about, how do you see the different roles and impacts and maybe the complementarity between legacy players and emerging players in moon exploration? Steve, would you like to go first?
Sure, it's actually a real pleasure for me to be here representing Blue Origin and representing the commercial realm. My career was in academia for decades. In that position, I worked very closely with some of the legacy players in the space world, and also, of course, with NASA very much. But I have felt, and I've said this, I've been saying this for some time now, that I think a big part of the future of space exploration lies in the commercial realm. And finally, after 30 years of doing rovers on Mars, I decided to vote with my feet, as they say, and make the shift over to the commercial world. And you know, the reason that I have felt that way is that as capabilities, as technology required to do really big, really meaningful things in space becomes more widespread, becomes more accessible, becomes widespread internationally. We see more and more nations, more and more different nations playing a significant role in space exploration now. But we also see many more commercial entities developing the capability, especially when they're well-funded enterprises, developing the capability to really take meaningful strides in space, and to do so in a way that is nimble, that is responsive to circumstances, but that also is very, very forward-looking and consistent in objective. You know, at Blue Origin, I sort of joke, but it's not really joking. Our tactical planning time scale is decadal, and our strategic planning time scale is on the century scale. We are able to have a long-term vision of what we want to achieve in space that is less subject to political pressures, variabilities in the political realm that might go one direction one year and a different direction the other year. We can remain steadfast in our purpose and going to the moon and developing a permanent human presence. Our long-term vision is millions of people living and working in space. And that is right now focused, and for the foreseeable future will be on the Earth-Moon system, on cislunar space. So we are able, as a commercial entity, to function in a way that complements what governments do, that complements what some of the big legacy companies do, and to fill in a role of providing services that will help build up infrastructure that I think is historically fairly unprecedented.
For sure, services is an important asset. Barbara, do you believe in this lunar economy?
Yes, I do. I just would like to share, as having sort of raised 3 SMEs in the last 25 years, I would say I'd like to share a little bit of what I think about these economy, the space economy, or better, I see it as an ecosystem. So it's like an orchestra where you have different components and you have different instruments, the big ones and then the small ones, and everybody plays a part. And I think it's very important that it is this diverse, the space ecosystem, economical ecosystem, and that it gives room for not only the agencies or the large system integrators or the new big emerging players, but also to the small medium enterprises or the micro companies who really can deliver a very different approach, a lot of innovation, a lot of disruption. They do things differently, but they also maybe create not only new business ideas, but they can also create new ways of working. And together, this, I see it as a sort of system where each component has a role and each component is vital, like in an ecosystem.
Thank you very much. And now we would like to close this conversation by inviting everybody to close your eyes for a few seconds. And the question that I ask each of you, but starting with René, close your eyes. If you have to envision, to imagine an infrastructure on the lunar surface in 5 years from now, what would you see, René, in 5 years? Be brave, but realistic.
Yes, hopefully I will see the Lunar 27 lander with our pilot system on board for a precise and hazard avoidance landing, and with our prospect drill for science. And maybe in addition to that, we can see first elements of our Moonlight initiative for things which we have heard from Matt about communication and navigation around the moon.
Yes.
So this will be my hope and vision for the next, for what we could see in 5 years from now. And maybe some rovers, smaller rovers.
Maybe some rovers in 5 years. Okay, Roberto, close your eyes. In 10 years, we are building, we are developing the infrastructure. So we start 5 years from now. In 10 years from now, Roberto, will you have your habitat on the moon?
Well, first of all, we will have the habitat around the moon. Very likely we will have the gateway operational and with full capability. Then we will have, hopefully, yes, initial habitat with, of course, the human landing capability. And maybe some logistic rover to assist humans and to build the infrastructure.
Okay, now we really need to expand, Steve. In 15 years from now, my dear, Blue Moon Plus.
2036. There's a lunar base, a real one.
Okay.
We have, can you hear me? Yeah, there's a lunar base, regular cargo deliveries, regular crew deliveries. We have just really begun sustained permanent human habitation. By 15 years from now, there's always somebody on the moon. There's always cargo on the way to sustain them.
Your landing pad.
The landing pads were there 5-10 years ago.
Yeah, but you forgot to mention. Okay.
I mentioned those earlier. The landing pads are already there.
Okay, good.
But the landing pads, the launch pads, you have fully reusable systems, reusable cargo landers, reusable cruise systems, and you got a base that's present on the moon, and there's a permanent human presence. 15 years.
Very good. I buy it. Matt, 20 years from now.
So in 20 years, I would see that those humans at that permanent base are taking real steps towards self-sufficiency on the moon. They are no longer just recycling air and water, but they're gathering their own air, say from water, ice on the moon. They're starting to generate oxygen from maybe even lunar regolith. They are growing their own food. So they're cutting that line from Earth, and they don't require continuous resupply. They're starting to be self-capable.
John, 25 years from now.
2046. So I agree with Matt that we have a maturing permanent base on the moon, maybe maturing in the same way that the bases on Antarctica have matured over time. So you have dozens of scientists and researchers there on long-term rotations. I see resources having been developed and now actually being used. So maybe a fuel depot on the surface, maybe one in orbit around the moon that helps you get back and forth to the moon and maybe helps you get beyond.
Barbara, will we bring our to the moon in 30 years from now?
In 2051, I think we will be on our way to Mars. So we will have understood that how to build sustainable bases, how to recycle, and to carefully treat resources, which we will also, use on Earth in our cities, in the everyday life to build, cities as spaceships. But we will also be already on our way to Mars.
That's beautiful. I believe that with this vision, we can our conversation. Obviously, if there are questions or comments from the audience, we are more than happy take them. Otherwise, I hope that you, the audience, there in St. Petersburg and from all over the world, I do hope that you enjoy as much as we did to, how can I say, imagine a possible development on the lunar surface of an infrastructure to which we all contribute from different point of view. Eleonora, if you want to close with the final slide, that was meant to be a memento that we can travel across the universe, keeping in mind that we always point to the place from where we come.
Thanks.
And thanks to the panelists.
And to everybody who made this possible, the organizers, the technical staff, the audience. Thanks. Thank you.
Yes, and a funny comment that's typical of me. If we succeeded in this GNF, how can I say, in a positive way, all together from different places, I'm sure that to build up a lunar base is an easy game, and so let's start doing that for real.
Thanks.
Thank you very much, Eleonora and Maria Antonietta, for this outstanding moderation, and of course the panelists for your great and very brave predictions. I really love this challenge which Maria Antonietta has given to the speakers. I mean, there are organizations that are working for years on doing this kind of roadmaps, and you did it like that. What will happen in 5 years, 10 years, 25 and 30 years? So that was just great, and I think everybody enjoyed it. Thank you very much once again. And we will close here with this GNF session, and we will continue with the next GNF session here in the room in about 5 minutes, and that will be a session organized by Lockheed Martin. So please stay in here or come back in a few minutes. We'll be ready in 5 minutes.